There we go. All right, everybody. I want to welcome you back to day 2 of the Python Web Conference. Thank you for joining us here for the Fireside chat. I hope everyone is having an awesome time. If you need any help, don't forget to duck into the help desk channel in the Slack, and we will make sure we get anything worked out we can get worked out. I see we're live on. We should be live across all the channels, all the tracks right now inside the Loudstorm platform. So if you're having trouble watching this, don't worry. There is a DVR feature, and if you missed the beginning, you can go back and see it again, or we'll have the recordings up momentarily. But I am really excited. Today, I am joined by Carl Meyer, who is a good friend of mine. I think we've met, I can't tell you how many years ago at PyCons and Django events, but probably more PyCons actually. I've not been to a Django event officially with you anywhere. But as a quick, kind of to get people settled in and a quick introduction, you've been involved in many of the projects kind of around the things where I'm also like with Django and such. But just give us a quick intro. And then in addition to that introduction, what was your first experience with coding?
Sure, thank you. Well, it's great to be here. I can't see all of you out there watching, but I think I probably know many of you. So hello to everyone. My name is Carl Meyer. I'm my first experience with coding, I guess, started at the beginning. I think I was about 8 years old or 9, and it was with a Texas Instruments TI-94A set-top box, solid state cartridges, and it had TI Basic built in, and but it had no built-in writable storage. So to get any kind of storage, you had to attach a cassette tape recorder to it through RS-232. And I never did, as an 8-year-old, like get that figured out how to do that. I'm not even sure if I had a cassette tape recorder handy. So everything that I wrote was written out in pencil in a notebook, and then every time I would turn on the box, I would retype it in
Wow.
scratch. So I guess that's one way to learn kind of a conciseness discipline in your programming, is to have to type everything in anew every time you turn on the machine. But yeah, that was my first coding experience.
I had the exact same system, and I had the tape cassette player to go along with it. So luckily I was able to load and save the programs off onto audio tape, which was awesome.
Never did that.
So you're currently at Instagram. Tell us a little bit about your role there and what you do.
Yeah, I've been at Instagram for about 4 years. And I've spent that whole time working in one way or another in server core infrastructure. So working with the Instagram server-side code base, which is a large Python Django app, which serves both the Instagram web application as well as the mobile clients, the API that serves the mobile clients. Some projects that I've worked on there. Early on, I worked on the efficiency team. I built a system that allows us to safely replay production requests in order to test out changes to see what effect they would have on production traffic in terms of efficiency or error rate or other things, but isolated in such a way that it doesn't actually cause any writes or any changes to any production data stores. That was something I worked on early on. Spent a few years working on introducing static typing into our server-side code base. So I've done a lot with that. We've gone from no type annotations to just about 100% type annotated on our server-side code base. And more recently, I've been working on some stuff in the Python language. We've got a project we're working on called Strict Modules that aims to tighten up a little bit what kind of things you can do at module import time, both to make it safer to import modules and also potentially be able to get some performance benefits out of having the code be a little bit more statically analyzable.
Mm-hmm. So I also want to remind folks who are watching, please put some questions. If you got questions for Carl, throw them into the Slido on the side of this video, and I'll make sure I can try and get to them. If there's duplicate questions in there, make sure you upvote questions so we can get those risen to the top. Now, Carl, you've been involved with the Django project in the past. What actually brought you into, well, I guess maybe first Python, but then what brought you to Django?
Um, I did some work in PHP for a while in the, I guess, late 90s, early 2000s. And then on the side, when I was writing PHP for my job, I ran across Mark Pilgrim's, I think
Yes, I
yeah,
remember this.
book, Dive into Python. It was online, and I ran through it, and I was like, this is a pretty cool language. So I started playing around with Python on the side. I did a side project. I looked around. There were so many Django web frameworks or Python web frameworks, but I really liked the Django documentation. Made things really easy to dive in and get started. So I guess that's how I got into Django initially. And then a few years later, I was starting up a web application development consulting company with my brother and my sister, and decided to kind of go with Python and Django as our default stack. So then for a few years there, I was working on client sites and applications in Django, and frequently fixing the bugs that I found in Django was more interesting than actually doing the client work. So I got into Django development.
Yeah. So actually, that's good. That brings up a next question, which was you've experienced now doing Django development or web development at like a small agency scale, and then also now going and doing it at probably one of the largest scales we know of, which is at the Instagram scale. I mean, what are the similarities and differences you see between those two types of operations, and are there things that one should be learning from the other?
Yeah, it's interesting. I mean, I've I've had the experience of going from one to the other, but not really back. And so I think at some point I'll probably have the chance to try to bring some lessons the other direction and kind of really see in practice what sticks and what doesn't. Um, Certainly, I mean, one of the biggest differences that I noticed early on, I came into Instagram right before we converted. I guess that's a project I missed in my earlier introduction. Basically, the first thing I worked on was converting our entire code base from Python 2 to Python 3 in the
Mm-hmm.
first year that I was there. Um, and so one of the first things that I observed that was very different was just the fact that at that scale, there isn't really the option to do kind of long running branches or to make large scale changes with kind of a flag day cutover where you like, convert the entire code base to Python 3 on a side branch and then one day you just merge it,
Right.
flip it over. That's just not at all feasible. And so one of the first differences I learned was, the need for any large change or really any change to be broken up into small pieces that can be merged directly into the master branch. And so that style of, I guess, continuous integration of everything being done in small changes that can be merged immediately and never having any kind of long running side branches. Definitely an early difference I noticed. Um, I guess there's lots of differences. I mean, a big one is just uh, the amount of engineering effort that goes into dealing with bad actors one way or the other. Um, just constantly being kind of bombarded with all kinds of creative ways to exploit or abuse the system, and having to kind of constantly do everything with that in mind is something that I think a lot of smaller projects don't get to the point of having to worry about. And then also just having the having the ability to, I mean, for the kind of infrastructure stuff I work on, having the ability to uh, experiment with things and collect data at very large scale to say, if we make this change on 1% of our servers, we can very easily compare what's the, how much CPU do we save, how many more requests per second can we get out of the system, that sort of thing is definitely a difference.
Yeah, no, I've noticed that as well. We run a smaller consultancy, and so we're finally getting to larger and larger projects where exactly that thing you said about the bad actors and dealing with like humans in general and the crazy things that they can do to your software. you don't get that exposure until you get a critical mass of folks actually like participating in the application itself. Now, you mentioned the Python 2 to 3 migration. That was an interesting, because they had a really good talk at PyCon 2017, I believe it was, in Portland about that.
Mhm.
I don't know if you wanted to kind of tell people, I don't know if there are tons of people still doing a Python 2 to Python 3 migration. What tips would you give folks who are doing that today?
Yeah, I mean, I can talk about how we did it at Instagram, and it worked for us. Having, I mean, I think the approaches that work definitely vary according to the scale of the code base you're trying to convert. Um, I would say our approach was less principled and more pragmatic, and I think that was probably the only way we could have done it that would have worked for us. I think at smaller scales, there would be ways to do it in a more principled way that could work. I mean, I'll give an example of that. Like, I think ideally, if you're transitioning a code base from Python 2 to Python 3, one of the key things you have to pay attention to is Unicode versus bytes, and just having a clear sense of where in your application you're dealing with Unicode, where you're dealing with bytes. And because in Python 2, they kind of silently cast back and forth without you having to really be aware of it, as long as you have only like ASCII data or whatever data happens to be. And in Python 3, they don't do that. So the ideal way to deal with that is to first in Python 2, make sure you have really good discipline around that. Use static typing or whatever you need to do to make sure that you're encoding and decoding at the boundaries and working entirely with Unicode internally and all of that. But I mean, if we had tried to do that at our scale of code base, it would have been months and months and months of work just to try to establish that discipline without even making any progress on the actual transition. So what we did instead is basically we started with the test suite, trying to get everything to import in Python 3, then trying to get the test suite running, and making a lot of use of utilities that were just utility functions that we could just wrap around a value and say, whatever this value is, give me back a Unicode or give me back a string or bytes. And so it was really just an iterative process of like trying to get more and more of the tests passing and just kind of fixing things that would break the tests, and just kind of doing that over and over again. And as we would get things working, of course, we'd have to write that in Python 2 and 3 compatible style so that we could merge that change in and have that test pass under both Python 2 and 3. So effectively, we had a list of tests that were known not to pass in Python 3, and we would run our test suite in the continuous integration system in both Python 2 and Python 3, and assert that everything passed in Python 2, and that the tests that were known to pass in Python 3 continued to pass, and then just over time continue to work down on that list of tests that weren't passing in Python 3 until it got down to nothing, and we had all the test suite passing in both 2 and 3. And then it was kind of repeat the same process, first on developers' workstations, convert them to Python 3, take reports, find out what broke, fix, rinse and repeat. And once we weren't getting more error reports from developers, then it's like roll it out to a small kind of pre-release in production, see what errors we get. So it was just that over and over and over again until then we have 1% of our servers running Python 3 and then 10%, and we're comparing performance. And we actually saw significant performance wins from Python 3 at that time. It was like, I don't remember the details, like 12% reduction in peak memory use.
Oh, wow.
Corresponding CPU use improvement. So that was nice to see.
So I assume that was the Python 3.7 then.
No, we initially ported to Python 3.5.
Okay.
So that was in 2017, I think, that we finally flipped the switch and had everything in production running Python 3.
Now, have you been maintaining the latest version of Python, like up to 3.7, 3.8, 3.9 now?
We're currently on 3.7, and we're in discussion about when we're going to get to 3.8. It's gotten harder. One of the things that the team that I'm currently on is working on is we essentially have a stack of patches on top of upstream CPython, which significantly improve Python's performance for our workload. We've done some work to try to upstream some of those, but it's obviously tricky because CPython covers many, many use cases, many kind of workload characteristics. And so it's one thing for our team to kind of really focus and experiment with our workload and find things that make a big improvement. But often those things could potentially be neutral or even negative for a very different type of workload. So it's not always easy to get those things upstreamed. So because of that, we're probably indefinitely going to be carrying the stack of patches, and the bigger that stack of patches gets, the more challenging it gets to upgrade to a new Python version.
Right. Now the main application is still a traditionally monolithic style application, correct?
That's right.
And what has there been discussions internally about, or debates of moving to microservices, staying on a monolith? What are the advantages of each that you have seen for Instagram?
Yeah, I mean, I think there's a lot of monoliths kind of get a bad rap, but I think they have a lot of advantages. Sort of our teams working within the monolith can focus on their business logic, and they really don't have to worry about, deploying their service or watching the health of it. I mean, we kind of have unified infrastructure that does continuous deployment every 10 minutes of the entire code base. And so there's kind of a whole set of a whole bunch of tooling that we kind of just build once and can take care of across everybody, and all the teams can do their own thing. And there's a whole set of kind of dependency and versioning problems that just go away. Like if you have an API that you've built that a bunch of different teams are using and you realize it needs to change, you just land a diff that changes the API and changes all the call sites, and it all rolls out at once, and there's never any kind of version skew issues. So, I mean, there's definitely pros and cons both ways, and it's not like it's an all in or all out kind of a thing, because we have extracted some things into services if they needed to be accessed from places other than Instagram server, or if it's really kind of a contained problem space that just, or sometimes because it needs to be written in something other than Python for performance reasons. There's various reasons we've pulled things out into services. So it's not like we haven't done any of that, but we haven't, and I don't expect that we ever will, like, devote a ton of engineering energy towards like completely breaking up the monolith into
So you mentioned like breaking up some pieces of the application into other languages. One of the questions that was actually asked was, what are some of the practices and tools of the Python ecosystem that we should adopt from other language communities? And are there some things we should be avoiding?
I mean, the easy answer on what we should adopt, I already said I spent a couple years working on static typing in our code base, and I definitely think like gradual typing is something that I'm excited to see Python adopting, and I think it's still kind of in its infancy today, so there's a lot of kind of rough edges when you work with it, and we haven't really even scratched the surface, I think, in terms of the benefits that it can bring. Like, I think long term, we can go beyond just having type analysis run as a kind of linter that's totally separate from the runtime, and we can actually make it more integrated, where the type annotations can really be trusted, and even trusted by the runtime and used to generate more efficient bytecode. And I think there's a whole kind of world of possibilities there that we can explore without kind of losing the dynamicism that we like about Python. So I think that's a really fascinating area for work going forward. So I guess that's something I'm excited about Python adopting from other languages.
Yeah. Are there things you hope we don't adopt?
That's a harder one, because I don't want to like pick on any language ecosystem and tick people off. I think maybe I'll skip that one.
Fair enough. We are dealing with the internet and humans, so you'll certainly hear about it. Okay, so here's another possibly controversial stance that I think there is interest in the room about hearing around scaling and asynchronous versus synchronous. I know there's some tweets going around even last week about this and benchmarks and kind of fallacies there and how they were calculated. So we've been hearing a lot of chatter about web frameworks going async because they are so much faster. And we've hearing the sirens call as well because it's new and sexy technology, correct? However, like I guess the added complexity of adding in like async and awaits for a relatively small user base, like buying a Flask or Django apps, has this is worth the time and the effort to adopt asynchronous, and maybe at what scale of projects does it matter? And so what guidelines on the payoff between code complexity versus the need for speed, if there is even a benefit in speed from moving that direction?
Yeah, that's a really good question. So we have over the last year or two, and I've only been sort of peripherally involved in this project, but we have moved our server code base to being almost entirely async, and we're now serving requests concurrently in a single process via async. So that's been a big project. I think at the risk of sounding kind of obvious, like async is a tool, and you really, like any tool, you have to evaluate like what problems you actually have and what's actually going to solve for you, and not just kind of it's the cool thing. I mean, we had a specific problem that it solved for us, which is, the monolith is quite large and it takes up a lot of memory, and to have in the previous model of synchronously serving requests, each worker process, we use uWSGI, so it's a pre-fork web application server, and each worker process that it forks takes up a sizable amount of memory. So we're bounded on a given machine of how many worker processes we can have. And then we have these relatively expensive worker processes sitting there spending half a second, waiting for a response from some backend service, and literally like sitting there and doing nothing. So that really limited our ability to fully utilize the CPU on our web tier hosts. And so async solved that problem, because with async we can, when one request is waiting for IO from a backend service, the process can context switch and run some other coroutines and do some work towards fulfilling another request. And so we have seen a significant advantage in terms of just how well we can utilize our machines to serve requests from doing that. Now, for many small sites, that's not an issue either, because your database is the only service, is the only real IO you're doing, and it's actually very close in terms of latency. And so you really don't waste that much time waiting for IO compared to the time you spend processing in Python, in which case that's not really a problem you have. Or just because it makes way more sense to, throw another 1.5 times the number of web tier hosts at the problem instead of putting all this work into change to async. I mean, so there's a lot of reasons why that wouldn't be a compelling reason, but it was for us. And there's certainly downsides, like, saying async is faster. Well, to be very pedantic about it, async is like 1.5 to 2 times slower in terms of the overhead of calling a single function, because you have all this extra work of creating a coroutine object. And then, so Python's doing a lot more under the hood with an async function. And our observation has been that if you don't consider the work the function itself is doing, you just look at the function call overhead, which unfortunately is fairly slow in Python to begin with, just to call a function. And it gets 1.5 times worse with an async function. So just in terms of sort of raw CPU usage, async is going to be slower than synchronous. Yeah, so pros and cons, and you really have to, I mean, there's other problems other than our problem that async can help with. Like, for instance, if you want to do more kind of reactive or asynchronous communication with a client, and then you need to that can be another reason to look at async solutions. So there's various reasons you might do it, but I guess the key thing is make sure you know what problem you have that it's solving for you.
Mm-hmm. Now, given the large code base and the number of developers and the number of times you're releasing per day to this application, how do you do code review? I mean, how do people get their code actually out to the the live servers?
Yeah, well, it's everything has to be reviewed, but the requirements on that are pretty uh, not too strict. I mean, basically, somebody else in the company has to look at your code and approve it. And once that happens, it can land, and the rest of the process is automated. So we use Fabricator internally. So you put your diff up on Fabricator, which provides a pretty nice code review environment with comments and all that stuff, suggested changes that you might expect. So people can review and discuss, and once it's approved, is ready to go, then you click a button and it gets landed on master or in the main branch of our of the repository, and then it rolls out about 30 minutes later, usually, to production. And of course, there's a whole suite of kind of safety checks along the way. So as soon as you push your diff into Fabricator, the test suite will run, or we have a kind of machine learning system which detects which tests probably ought to run based on which code you've changed. So a certain subset of tests will run when you push your diff and give you some signal, you and your reviewers. Then when you actually want to land your diff, the entire test suite will run, and it will also get canaried onto a few production servers for a few minutes to see if error rates go up or anything else notable changes. And then when it gets rolled out, it'll first roll out to, I think, like 2 or 3% of the servers. And again, watch a bunch of metrics there. The automated system checks a bunch of metrics, and if everything looks good, then it automatically rolls out to the rest of the fleet.
And so about how many releases per day are done at Instagram to the main monolith?
I am not even sure if my numbers are up to date here. I think the last number I saw was in the realm of 150 releases per day. It's basically a release every 10 minutes from like 6 a.m. to 9 p.m. Pacific time.
And you maintain there's no branches in your code repository, correct?
No branches. Everything is just diffs that land and then roll out.
It's just mind-boggling, I think, for folks who are in branch land and doing Git flow, workflows, things like that. I look at that complexity, and then I hear you tell stories of, there's a single branch and there's only one main line of code in the whole repository, and things just flow out to the internet. When code lands on one of those canary servers for a couple minutes, I mean, how many people see it? Do you know about how many requests hit that?
I don't have exact numbers on like requests per second at a single server.
Yeah.
But I mean, obviously it's a very, very tiny fraction of the overall user base would ever hit a particular canary, but that's still a lot of requests. Certainly enough to get signal on whether it's good. Yeah, I mean, the whole thing about like really continuous integration in the sense of like integrating all your changes very frequently into a single mainline, it has its own trade-offs in terms of complexity, right? You trade one kind of complexity for another. You don't have the complexity of managing these branches and how they relate to each other. And well, if I'm starting some work, should I base it on your branch or base it on a lot of those, and like all the rebasing and resolving conflicts? That stuff is much reduced. The kind of complexity you get instead is that, if you're developing a big feature, you have to you have to sort of incrementally work on it behind kind of a feature gating system, so people don't see the incomplete feature. And so there is complexity there in terms of your code base. Your main line of your code base isn't as clean in some sense. It doesn't like represent some ideal of the current product. Instead, it's got all kinds of like half-finished experiments and Python 2, Python 3 polyglot code all over the place when you're doing that transition, because you can't just do it all at once. So you do trade one kind of complexity for another, but I do think there's a lot of advantages in terms of, I mean, the whole point of continuous deployment, right, is that we roll out a small set of changes with every rollout. So even though we're rolling out constantly and that seems risky, when something bad does happen, we can detect it very quickly, and we can very quickly roll back to a known good release with a very small delta of the actual changes we're rolling back, and not catching up a bunch of unrelated changes in that rollback. And that's the big advantage in terms of safety. And if you try to do continuous deployment, but you still do these big branches, then you still end up rolling out massive changes to your code base all at once. And so that means when something does go wrong, it's much harder to figure out what exactly did go wrong. And so I think there's a lot of advantage to
Right.
being a feedback loop as tight as possible and making the changes as small as possible.
I mean, about what is the size lines of code wise of a change going into a release?
I mean, they can be big. Typically, the big ones tend to be fairly mechanical changes where, it's like someone changed an API and then just did an automated kind of modification of like all
not that someone ran black against the code base all of a sudden.
Well, I did actually do that at one point a year ago, but I didn't do it over all the code base. Again, that's the kind of thing where that'd be way too big of a change. So it was like, I think it was something like 30 diffs, basically broke the code base up alphabetically by top level directory and just kind of hit one at a time, rolled it out over time. But yeah, so we do have big-ish changes that tend to be the more mechanical ones, but I would say the typical kind of changes we're rolling out are touching, 1 to 4 files, a couple hundred lines of code changed.
Yeah. So a question from the audience was, what version control system are you currently using?
We use Mercurial.
Mercurial?
Yeah.
Because it's Facebook.
Facebook uses Mercurial. I mean, there is some Git internally for different things as well, but the big projects are all in Mercurial. And really the reason for that, as I understand it, was just that Mercurial was more, there was a point where there was kind of a decision being made and Mercurial was more hackable, and the Mercurial developers upstream were more kind of interested in contributions that would make the system more modular. And so at our scale, there's changes that have to be made to the version control system to make it function efficiently. And it was easier to do those in Mercurial than in Git.
Yeah. And we spoke previously, and you're in the tens of thousands of unit tests for the code base. How long would that take to run if they all ran serially?
I don't think anyone knows. I don't know that anyone has ever completed a serial run of all of the unit tests for our code base. There's a lot of tests. I think we might be over the 100,000 mark now. I'm not entirely sure. But yeah, in actual practice, we run them distributed over a whole bunch of different machines. And it takes like 10 to 12 minutes. But it would be many hours to run them all sequentially.
Wow, that's crazy. There's another question here from the audience, which is, if you don't branch, what do your CICD mechanisms or practices look like? Not talking about the CICD tooling, not talking about CICD tooling, would like to know about the dev culture and adoption.
Huh.
So maybe they're asking if, has there been, how long has CICD been a thing at Instagram, and maybe that's even before your time there?
Yeah, that's a good question. I actually don't know the full history there in terms of what was done in the early days, like before the Facebook acquisition or before I arrived. Certainly, it was well established as the practice when I got there. Yeah, I don't know. I'm not entirely sure if I understand the question in terms of like adoption. Basically, for an Instagram server developer, it's not really
it's not an option.
It's just the way things work. And I think by and large, it's pretty nice for developers in that like you make changes, the tooling is all very kind of nice and streamlined, and your change gets approved and you click a button, and then like 45 minutes later, it's in production. So
yeah,
we certainly don't see a lot of complaints from developers about that.
Right. So how I guess what advice would you give to an organization looking to move that direction? Maybe what changes in their culture could aid in adoption? Maybe that's more what the question's about.
Yeah. Well, I mean, Um, this is where I feel like I should be clear that I'm moving from like things that I actually know and have observed to things that I'm speculating about, because I arrived at Instagram with this already in place and didn't participate in actually moving an organization to this way of operating. But um, I think you really have to get uh, buy-in that it's basically a safer way to operate, to roll out small changes frequently in an automated way, um, rather than rolling out sort of massive changes uh, with a lot of kind of manual work to do it. And I think if you basically have buy-in that that's a better place to be, then I think you can make the transition to doing it.
Yeah, I think that was the spirit of the question because he actually followed up saying, "How do you train new developers in this manner?" So it sounds like it's getting that buy-in, and I guess how do you sell them that that is definitely a better way?
Yeah. I mean, at our scale, it's sort of like I said, it's sort of like there's no option in the sense of if a developer would come in kind of with a different mindset and would kind of go off and work on a massive set of changes for a long time, and then kind of get it all done, and then try to land it as one big diff, they would pretty quickly learn their lesson, because a lot of things would have changed under them in the code base during the time they were, just because of the size of the code base and the number of developers during the time they were doing that. And they would kind of have a very hard time rebasing and bringing their changes up to date. So uh, I think developers kind of learn from their own self-interest to
Yeah,
try to make smaller diffs and get them landed quicker to avoid
right.
problems.
I was gonna ask about that. How specifically? Well, with 150 releases per day, obviously many changes happening all the time. Uh, you have to have a way to get new features into production, and you also have to be guarding against backward incompatibility. I assume you can't make changes to the database that is, as a new migration rolled out, breaks the things from, well, even an hour ago. Now, how do you manage that, like that complexity of like new features and database backward compatibility?
I mean, I would say a lot of things just become sort of more work, but I think you quickly just, I mean, it's obvious that there's no other option. Like there's no way that we can do sort of synchronized database schema migrations and rollouts. Like that's just not even in the realm of possibility. So you just start to think about the changes you need to make in a different way, where you assume forward and backward compatibility as a requirement, and then you kind of just do the work. I mean, I think we all kind of can approach a problem like that and pretty quickly see what needs to be done in order to make the change incrementally with a series of safe changes. It's just that if we don't have to, we don't necessarily feel like doing all of that extra work. But I mean,
Right.
when you have to, you just do it. You add a field, and you then slowly like migrate data over from an old field to a new field over time, or just whatever you have to do to make it a forward and backward compatible series of changes.
There's a question now. Obviously, Instagram deals with images. What do you do with images on the back end? Are there image adjustments handled entirely on the client apps, or are there back end processes that are doing some manipulations to the images? And with the specific question was, are you using libraries like Pillow, like open source Python libraries to do that, or something else?
Um, so this is an area that I haven't worked a lot in. My understanding is that most of the image manipulation stuff is done on the client. Uh, there may, I know that we have Pillow in our dependencies of our server-side app, but I haven't spent a lot of time looking at what it's used for exactly. So I'm not really sure.
All right.
I guess
We'll have
maybe
to,
that points to another difference of working at this scale, is that like uh, there are huge sections of the Instagram product and the Instagram code base that I really have very little clue about. I mean, I probably ran black over them at some point, or added to them at some point, but that doesn't mean I actually know what they're doing.
wow. So you ran black over them? Are you continually running black now and enforcing black as a code style checker?
Yeah. So black runs
Oh
every time.
wow.
Black runs in everything every time you submit a diff, and um, and yeah, the main branch is always fully blackened.
Have you seen an advantage to doing that? Has there been a benefit or an upside, or is it just us developers loving things fitting in a certain box?
No. I mean, I think developers have loved it. I mean, just the consistency that it brings over the whole code base with so many developers working on it. You can always expect, I mean, you know, you can always find cases with Black or any auto formatter where it makes a choice that you're like, I would never have made that choice. But certainly for us, any issues like that have been far outweighed by just the benefit of having it be the same everywhere, and you never have to discuss code formatting on any diff review ever. It's just a solved problem, and you don't even think about it. That's been very positive.
That's awesome. Now, considering the scale of Instagram and the types of changes that go into the code base, there's an opportunity for things to dramatically slow down prior to release. How do you performance test or load test code before it even goes into production? I assume that must be part of the canary process, but you must have another thing before it even gets there. Can you talk a little bit about how you detect issues that are going to affect this kind of scale?
Yeah, so I mentioned earlier one of the first projects I worked on was a sort of a traffic replay environment where we can take a version of the code and spin up a web server running that version of the code, and then fire requests at it that actually come from real production traffic, and then serve them, but in an isolated way where we ensure that nothing can escape and touch actual production data stores. And so that system, uh, any developer can run that on their diff and quickly get a report saying what the effect was on the CPU that it took to serve those requests, or if they were served more slowly or whatever. So that's one thing that's available for that. And then beyond that, we really just rely on the automated rollout mechanisms. Like when we roll out a diff initially to a small percentage of our fleet, we watch a number of metrics on that sort of section of the fleet and compare them to the rest. And if there's a huge regression in terms of CPU, then it'll automatically halt the rollout pipeline and not continue rolling that out. And oftentimes smaller regressions do get out to the entire production fleet. And so at that point, we have sort of another entire tool chain to detect those CPU regressions, to try to assign them to a particular rollout based on timing of the change, and then even automatically file a task to the developer who made that change to say, hey, we observed X% CPU regression on X endpoint when your diff rolled out, and then it's up to that developer to address it.
Nothing like public shaming to affect change in an organization, right?
Well, we usually keep it not too public. Nobody else is going to see the tasks that have been filed against you until they unless they go looking for them. But yeah, I mean, the other thing that we have to do is kind of at the larger scale. Like obviously, new features are going to have new costs in terms of CPU, and making changes. Sometimes you can make a change in a very easy, simple way that then costs some CPU, or you can do a lot of extra work to kind of bring that cost down. And so developers are constantly making these trade-offs. And so as an entire organization, we have to kind of figure out how to budget this, right? And so we end up kind of assigning budgets to teams where a given team will have for the year, for the half, you know, you're allowed to spend this much CPU regression in order to achieve your goals as a team. And whether you choose to spend that by making kind of careless changes that cause regressions, or by launching new features, or whatever, however you want to spend your budget is up to you, but you can't go beyond this budget. And if you do,
Yeah.
you have to put in some work to bring it back down.
All right, we're coming right up to the end here, and we got like 2 more minutes left. We have a wide range of attendees at the conference today, and I think there's some budding new web developers. I think it's maybe a parting words for them. What would you encourage folks to do to kind of spin up their web development skills, get to the next level, improve their career? We've got folks who are around the world in all kinds of different socioeconomic areas that could really benefit maybe from that.
Yeah, I guess My advice would be A, build things a lot, and B, as you're building things, like be really curious about the tools that you're using and what they do and how they're doing things internally. And so don't just be satisfied using Django and reading the documentation, but really, like, when you run into something that seems weird, like dive into the code. It's all just Python, and um, you can learn a lot just by being curious as you're building.
I mean, that is some of the best advice I give folks as well, is to be curious, break things, fix it,
Mhm.
understand it. All right. Carl, thank you again so much for being with us today. I really appreciate all your insights and being able to share with us, how things kind of, how the sausage is made on the backside of Instagram a little bit. And I think the community as a whole has benefited. So we have a gallery room. If you don't mind joining that gallery in the session, so that people can maybe ask a couple face-to-face questions that they didn't get to ask during the actual session, that'd be great. And I assume you're logged into the Slack channel. If people want to ask you some direct questions or want to come into the keynote track and ask questions to you, they should be welcome to do that.
Sure, I'd be happy to. Yeah, it's been great to be here. Thank you.